Hello again, this is Max. Max and I, we are going to be explaining a little bit about network fundamentals. Network fundamental is going to be split in two parts. On one side, we're going to be talking of the network traffic types, and on the other side, we are going to be talking about network architecture. So Max, you're going to be ready to understand that because the whole scenario of networking, we need to understand those concepts, and those concepts are going to be very important before you apply those to the protocols, EGRP, OSPF, RIP, or whatever, BGP. So this is a very important part that I want you to understand, specifically when we're going to be touching the NBMA part of the architecture. So there are certain things that apply and certain things that doesn't apply. So stay focused, and we're gonna be checking on you right now, guys.
Hello guys, this is Victor, and we're going to be talking about network technology fundamentals. We need to understand this because traffic flow is determined by traffic type and network architecture type. This is going to be determining as well the troubleshooting and the design of your network. So let's start working on that right now. The traffic types. What are the traffic types that you're going to find? We're going to find unicast, multicast, broadcast, and anycast. And on the network architecture type, we're going to find point-to-point, broadcast, and no broadcast multi-access, NBMA. Why this network technology is fundamentally important for you guys? It's gonna be part of the network principles. It's gonna be the base of everything that you're gonna be doing. It's gonna be affecting as well. That's the first part that you see over here, and it's gonna be affecting as well the layer 2 technologies and layer 3 technologies. We are basically talking about the IPv4, IPv6, and the protocols that you're gonna be using the most, especially in this class, OSPF and IEGRP. So let's start talking about network traffic type. We're going to be talking about UNICAST mostly. The first one of the whole list. Remember that the whole list is UNICAST, multicast, broadcast, and anycast, as we mentioned before. So with UNICAST, the traffic travels from a single source device to a single destination. So you're going to see over here, for example, a server that is sending all the information through the switch, and it's going from 10.1.1 to 10.1.1.2, and it's going to 10.1.1 as well. We want to talk about broadcast as well. Broadcast traffic travels from a single source, for example, and it's going to travel to all the destination in the subnet, and that means as a broadcast domain. Over here you can check that we have a subnet of 255, 255, 255, 255, and it will reach all the hosts in the network that we're going to have. One over here, one over here, and one over here, and it's going to be reaching all the devices in the single network with the destination 255, 255, 255, 255. So now we want to talk a little bit about multicast. On multicast, it provides a technology where a single host sends a traffic to multiple but very specific destinations. So, for example, you have a company over here that has 300 users, and from the company that has 300 users, you want to send a video in multicast to the people from the marketing department, and the marketing departments, there are only 15 users over there. So you're going to be choosing a class D address, for example 239.1.4.5, that represent the address of a subnet on a multicast group that is the marketing group, where all the people in this marketing group are going to be the ones that are going to get that multicast. Now we want to talk as well about anycast. With anycast, a single IPv6 address, and I want to make sure that you understand this. This is not IPv4. Is assigned to a multiple device, as you can see over here. It goes over here to the clouds, and from the clouds, it's going over here, and after that, it's going to the devices that we want, and the communication flows in one to the nearest. One to the nearest in the routing table. So guys, I hope that you understand that part, and let's talk about the network architecture type. Remember that this is going to be affecting the design and the troubleshooting skills that you're going to need for the network that you're going to have. And more specifically on the NBMA, something that we're going to talk in a couple seconds. So we have point-to-point network, the most basic, broadcast network, and no broadcast multi-access network, NBMA. So you have your network. How are you going to plan to design that? We have point-to-point network. That's the most basic one. And the segment consists of a single network link connecting two different routers. And mostly you can find that situation when you have serial links. No broadcast network. In a broadcast network, the broadcast is sent from one router, like the one on the top that you see over here, and it's propagated to all the routers in that segment, like here and over here. And you're gonna find yourself as well with a NBMA, no broadcast multi-access network, but that have an issue, as its name implies, it doesn't support broadcast. Like the graphic over here, and like the graphic over here, then they are going to a very specific destination. The access of broadcast support, it also implies an absence of multicast support, and it can lead to a lot of issues with the most popular routing protocols that you're gonna find, for example, OSPF and EIGRP. Why? Because you're gonna need dynamically those networks to form network relationship with the other router to discover through multicast. So how are you going to connect, for example, you both router, three routers, for example, $160 in eBay, as you say, hey, that's a very good deal. And you try to connect that. There are very good Cisco routers. You have the review, but you are not able to you do the proper configuration. You buy the cables, and then the next day you are pulling your hair because it's not working at all in the way that it was supposed to do. Why? Because no multicast is allowed in NBMA network. So that can have that issue very specifically, but it as well can have more issues in the NBMA environment. For example, when we have a split horizon, in a split horizon, basically what it says, the routes learn on an interface from being advertised back on the same interface. For example, you see over here, router A learn about router C through router B, but it cannot advertise again. And router A learn that stuff through the interface F00 that you have on your router, but it cannot send information back to the router B about the router C directly from that interface that we just mentioned right now. So you're gonna have some issues preventing router A to form advertise very specifically with the router C. So after you both your three routers on the Amazon, you know that there is a problem with the configuration, and you don't need to be pulling your hair. And the other stuff that we're gonna find is a designated router issues. As you remember, when you study CCNA, OSPF added a designated router The designated router is the one is the router that connect with all the other network segments to form adjacencies over here. Remember that we have a backbone over here that is gonna be the area 0 and it's connecting through the other networks over here. In this case scenario, what I would suggest is that you set the priority 0 on this router over here and this router over here. So you're gonna start doing some configuration with the designated router very specifically in an OSPF architecture that you have over here. So guys, understand NBMA and understand network architecture for a lot of issues, for a lot of circumstances, is going to be very important before you do the configuration of the network that you have. We're going to be explaining that way deeper in several next videos, and I hope that this video was informative for you, and thank you very much for watching it. Have an excellent day.
Hello guys, thank you very much for coming over. This part of EIGRP is very important, so you understand a little bit about the architecture and how those apply very specifically when you are using that with the different protocols, and what are the steps that you need to do for after you understand this whole concept. After you understand this, we're gonna explain a little bit more about important technology that you're gonna be applying for the CCNP route. Don't forget to subscribe over here and click like as well, so you're gonna keep this channel alive. Thank you very much, and thank you for watching.